Good morning. How are you? Okay. On Monday, we began our journey into financial arithmetic, computation, namely compounding and discounting, computing future values, computing present values. Today's lecture is a continuation of previous lecture. Last class, we discussed how to value a cash flow, single cash flow as of today, or cash flow value as of some future date, so-called future value, and today's value, so-called present value. We discount future cash flow to compute the present value. We compound cash flows to compute the future value. We were talking about valuation of a single cash flow, one cash flow. Today we are extending that over to many cash flows, not just one, but more than once. Multiple cash flows are valued in the same way as a single cash flow is valued, both present value as well as future value. And we'll discuss that. And we'll talk about a very special case of multiple cash flows, so-called annuities and perpetuities. So these are the outline, future and present values of multiple cash flows, and valuing level cash flows, annuities, and perpetuities. Here's a simple example. Suppose you invest $500 in a mutual fund today. Mutual fund is a investment instrument which invests for you in stocks and bonds and securities. Suppose you invest $500 in a mutual fund today and $600 in the same mutual fund in 1 year. If that fund pays 9% annually, how much will you have in 2 years? You've seen this kind of problem last class. How much is your account worth in 1 year, in 2 years, right? So first cash flow of 500 occurs, and it is compounded twice to find year 2 value of this cash flow, and $600 compounded once to find year 2 value, and add them up, you have future value of the multiple cash flows. So this is simple extension of single cash flow valuation. All right? Easy. Any questions, comments? So you understand. Okay. We'll move to the next step. Continuing the same problem, how much will you have in 5 years if you make no further deposits? In other words, first year you put 500. As of time 0, you put 500. And time 1, you put 600. And then you don't add any further deposits into your account, into your fund. But fund will grow because the amount invested in the fund will keep earning returns. And if they are expected to earn 9% interest, then what would be the value of your account in year 5? So remember, you had 500 in year 0, and you put 600 in year 1. Okay. And year 2, your account value is 1248, correct? And that is invested at 9% for 1, 2, and 3 years. This is how you computed it. Okay? 1248 invested in year 2 and they grow in value at 9% per year over 3 years to yield 16, 16, 26. Okay? That's year 5 value of your investment. Year 0, you put 500. Year 1, you put 600. And let them grow at 9% per year. And your end of horizon value is 616. Okay? Alternatively, what you can do is year 0 cash flow, compound it once, twice, 3 times, 4 times, and 5 times. That's 500 times 1.09 to the 5th power. And year 1 cash flow of 600 is compounded once, twice, 3 times, 4 times. So 1.09 to the 4th power. And add the 2. And the rest of the years, you don't have any further deposits. So you don't have anything. 500, 1.09 times 5th power, compounded over 5 years. And 600, compounded over 4 years. Are you with me? Okay? So there are many different ways to compute the future value. There is no such thing as single, the only way. Okay? There are many different ways. Okay? The second way is the first way I gave, and the first way here is the second way I gave to you. So I want you to realize that there are many different ways. Whichever is you feel more comfortable with, just use that. Any questions? Comments? Okay. I will make your life a little more miserable by going into this. Suppose you plan to deposit $100 into an account in 1 year. Notice that this is not an investment as of now. In 1 year, you are going to put 100. And year 2, you put 300. When you see this kind of problem, it is recommended that you draw a timeline. That will make it easier for you to understand and formulate. So timeline, 0, 1, 2, and it goes all the way to year 5. And you plan to deposit 100 in year 1 and plan to deposit 300 in year 3 and nothing in other years. And you'd like to know what your account is going to be worth in time 5, year 5, at horizon. So how would you do it? What is the year 5 value of your account? 정광이, you try it.
Isn't that a solution?
Yes, this is the solution, but assuming that you can't see it.
Using the formula, the 100
100. Explain in words. 100.
as the
Investment.
1 plus 8%.
That's 8% interest.
And power of 4, which is the year.
Okay, 4 times. Once, twice, 3, and 4 times. Right? 4 years. Okay, good.
Do the same thing with
Once and twice. Right? That's what it is. What's it up there? Okay, good. 485.97. So this is easy, right? Once you think of it, there is nothing difficult in it. The only thing is it's cumbersome, it's tedious, and your fingers become tired. Okay, but don't feel tired. Be excited about your fingers are doing your work. Are you with me? You understand this? Okay, we'll move one more. This time, instead of computing future value, I would like to ask you to think that you have set of future cash flows and you would like to bring that back to present. You would like to find the present value of it. So let's draw a timeline once again. By drawing a timeline, you can formulate the problem much easier. Here's time 1, 2, and 3, and 1,000 in year 1, and 2,000 in year 2, and 3,000 in year 3. You are considering an investment that will pay you 1,000, 2,000, 3,000 in 3 years. You want to earn 10% on your money. So 10% interest is effective for all those 3 years. How much would you be willing to pay? Okay. This is the cash flow that you are going to have. If that's the case, how much would you like to invest for this cash flow? How much would you be investing to be happy with the cash flows that will occur over 3 years? So you are investing amount called X, and you expect your investment to yield 1,000, 2,000, and 3,000 in year 1, 2, and 3 respectively over a 3-year period. So you are giving up the amount called X. You are giving up present value of X. Okay? And in return, you are going to get 3 cash flows in the future. And you want to compare the 2 options. One is keeping X. I have X. And I have an alternative that is to earn $1,000, $2,000, $3,000 in the next 3 years. The difficulty is X is today's value, and the cash flows are in the future. So you cannot compare future cash flows with today's cash flow. So you have to convert these future cash flows into present value to see whether you should give up X to find that. So let's find present value of future cash flows. And all you need to know is present value formula. You remember? This discounted once. Discounted once. And this one discounted twice. And this one discounted 3 times. That's that. Okay. The present value is 4,815. 4,815. So this is the value. This is the value of the cash flows that will occur in the future. Okay? 4,815 is the value that you will receive over a 3-year period. That's today's value, present value of future cash flows that you will receive. And you are comparing that amount with the amount that you are giving up. If X is greater than this number, then you will not give up. You don't want to invest, because by investing, you get less. If X is smaller than present value, then you should invest. By investing X, you get more than what is worth. Okay? Are you with me? So this is the timeline we saw. And move to the next slide. Multiple cash flows using a spreadsheet. I tried myself. And I spent about 10 minutes to figure out what the spreadsheet really says. I decided I gave up. I told you not to give up, but that one I gave up. So the things that I gave up, you can give up too. Okay? Instead, in present value, future value computation, typical questions students ask me before an exam is, do we have to memorize all those formulas? And my answer is no. No. If you need a formula, ask me. Professor, give me a formula, and I will provide it to you. Okay? So don't try to memorize formula, except the ones that I say you should memorize it. Okay? And today, I'm giving you one such formula that you should memorize. Not only memorize, you should take it as part of yourself. You already saw that. Future value at time t is equal to present value times 1 plus r to the tth power. And the other side of this coin is present value is equal to future value at time t divided by 1 plus r to the tth power. Okay? This is all the formula that you need to memorize. Not just memorize, you should have it with you. Don't try to memorize. It's becoming part of you. It has to be inside you. It's already carved, etched in you, so you will never forget. Okay? That's part of you, so you will never forget, right? Like your name or your birthday. Okay? Other than this, there's nothing to memorize. Okay? Using these formulas, I want you to do the following discount cash flow problem. Your broker, who appears to be very sweet-talking, calls you and tells you that he has this great investment opportunity. Okay? He has got a great investment opportunity for you. If you invest $100 today, you will receive 40 in 1 year and 75 in 2 years. If you require a 15% return on investments of this risk, should you take this investment? Don't look at it. Okay? Don't look at it. Don't look at this side. Of course, it's hard not to look at it. It's up there. But just pay attention to me. Okay? Here is a timeline. This is very critical, time 0 and 1 and 2. And your broker is asking you to invest 100. Right? And he will give you 40 in year 1, and he will give you 75 in year 2. So you invest 100 and receive 115 if you ignore the time value of money. Right? If you ignore the interest, then you invest 100 and you receive 115. And the story already sounds very fishy. You are earning 15% interest on your money, and you are given this opportunity, and your broker is talking you into this deal that I will give you 40 this year, next year, and 75 the following year if you invest today 100. So your broker is asking you to invest 100. If you invest, then you get this, right? So let's call that option 1. Option number 1. Invest 100 and get this. Alternative to that, let's call it option number 2. If you don't invest, what do you do with the money? Just do nothing, okay? So do nothing. If you don't do anything, then your $100 will stay with you, right? That $100 will be staying with you. That's present value of 100. You're comparing that option with this option. If you invest, then you are going to have 40 and 75. So you are giving up 100 in order to get this. And what is the present value of these two cash flows? And compare that with the nothing alternative of 100. So let's find present value of 40. Let's do this. 40 divided by 1.15. That's present value of this cash flow, discounted once. And this one, 75, 1.15 squared. Right? That's using this formula. You already know it. The present value of 40 plus present value of 75. And if you compare, if you have that, that's equal to 91.49. So look at these numbers very carefully. If you invest the amount, 100, you are going to get 91.49. Not actually. You are going to get 40 and 75. But the present value of 40 and 75 as of today is 91.49. So what it is you give up 100 and get 91.49. Is it a good deal? You are giving up 100 to get 91.49? That's ridiculous. Right? That's ridiculous. You wouldn't do that. That's what it says. No, the investment costs more than what you would be willing to pay. You are willing to pay 91.49. That's the value of it. You are willing to pay 91.49 and you get 15% interest on 91.49. You don't have to put up 100. Okay? Does it make sense? Okay. Then let me ask you to do this exercise. This is a simple exercise. Look at the same problem, but let me use different color. Okay. Option number 1 is same. You invest and you receive 40 and 50, 75. Option number 2 is instead of, I shouldn't have erased it, but that's up there, so, okay. Option number 2 is instead of do nothing, I invest 100. And I invest and get 15% interest. Okay? Instead of investing in the deal, you are investing by yourself to an opportunity that gives you 15% return. So year 1, you have 115, right? And reinvest it at 15%. And how much will you have? 15% and 15%. How much will you have? 132.25. In the first option, you invest 100 and it gives you 40, right? Reinvest 40, reinvest 40 at 15%. How much will that be? 40 times 1.15. Huh? 46. So 46 plus 75. How much will that be? 121. So look at this. This is funny. If you follow your stockbroker's advice, your money, investing 100, it will become 121. Following your stockbroker's advice. But if you follow your own instinct, investing at the market opportunity of 15%, then you end up 132.25. So you are ahead by following your own instinct rather than following stockbroker's advice. This one is nothing but the following manipulation. 40, when you receive 40 in year 1, compounded once, plus 75. That gives 121, right? Divide both sides by 1.15 squared. Okay, 1.15 squared. Then it will be 40 divided by 1.15 plus 75, 1.15 squared. And that will be equal to, how much is it? $91.49. Wait, we already saw that, right? This cash flow can be compared as of time 2 values. Option number 1, your stockbroker's advice, time 2 value is 121. If you follow your own instinct and investing in the market opportunity, you will end up 132.25. So your investment option is better than the stockbroker's advice. Right? Exactly the same thing we did. As of time 0, you compared 2 options. One is do nothing and keep your 100, or investing something to get this cash flow. All you need to invest to get this cash flow, 40 and 75, what you need is 91.49 instead of 100. So if you compare it as of time 0, you still come ahead with your $100. Okay? If you compare that as of time 2 future values, again, your option is better than stockbroker's option. Notice what I did is to compare the 2 alternatives at the same time. In other words, when you have more than one alternative, then you compare those 2 alternatives as of the same time, as of present value or in terms of future value. Do not compare present value with future value. Okay? Present value with present value, or future value with future value. That's what I'm trying to get at. Okay? this simple example tells you that there are many different ways to interpret this discounting and compounding. Okay, the next. This is a bit more complicated. Sounds complicated, but it's not. It's also applying the same principle of compounding and discounting. This one is a long time horizon, okay? In year 40, you are right here. This is a retirement problem. It's funny. Very few of you have started your professional career yet, okay? And I'm talking about retirement. But you have to think about it. At one point, you will retire. My case is coming much faster than yours, right? Time zero, that's today. And you look into 40 years into the future. In 40 years, you will retire. And when you retire, you are going to get $25,000 in year 40, 41, 42, 43, and 25, 25, and 25. You are going to get these cash flows way into the future, right? And how much would you have to invest or save today in order to be able to have $25,000 each year for the following 4 years, starting in year 40? The formulation is okay. It's understandable, right? How much would you have to invest? Well, this is, again, present value computation. 25K discounted over 40 years, 25 for 41 years, 42 years, and 43 years. So 40 divided by 1 point, what's the interest rate? 12%. To the 25. 40th power plus 25. 1.12 to the 41st power plus 25. 1.12, 42nd, 25. 1.12, 43. And the answer is 1,084.71. Little more than $1,000 you invest, and in 40 years you will have more than $100,000. So this is the power of compounding. Those of you who find this problem interesting, you might want to try the following exercise. Okay? The following exercise. Let's say year 39 is your target year. Okay? Year 39, you... What? Oh, one more. I'm sorry. Sorry. 25. 1.12, 45. Thank you. 44. Okay. A monkey can fall from a tree. Are you with me? Now suppose, think in this term, okay? What we are doing is comparing today's dollar with today's dollar. Okay? In other words, 25,000 each year for 5 years, discount it back to the present and present value of the cash flows with the amount that I invest. Okay? That's what I did. But instead, I want you to think in this term. In year 39, you look at your life. 39 years have passed, and you look at the future. Next year, I need 25K. The following year, I need 25K. Since I'm retiring, I need income from my investment. And 25K for the next 5 years. So year 39, I look at my future and 5 years cash flows, level cash flows over the next 5 years. So year 39, I ask myself, how much is my retirement income worth as of today? That's year 39. Right? You can do that. Right? So how? 25, 1.12 plus this 25, 1.12 squared plus third 25, 1.12 cubed plus 25, 1.12 fourth. The last 25, 1.12 fifth power. That's the present value of retirement income as of year 39. Okay? Will someone compute this for me? Come on. 100. Huh? 143 point. Come on, anybody? Make up your mind. I didn't calculate it myself. Uh, 143. 143, 442. Okay. Okay. Let's suppose that this is right. Okay. No, it doesn't look right. No, it doesn't look. It can't be right. Can't be right. Huh? 90 something is right. Okay, tell me. 90. 90.119. 90.12. Okay. Now I want you to find that today invest 1085. Okay, invest 1,805 over 39 years at 12% interest. Okay? And how much will this investment be worth? Begin calculating. Today you invest 1,085, and invest in the opportunity that yields 12% over 39 years. Okay? That's future value computation. This is nothing but 1085 times 1.12 to the 39th power and 90,000? Yeah, 90,000. 143. Okay. Okay. That's good enough. That's good enough. This one and this one, very close, right? Because of rounding. Yeah. Do you see the logic? This amount is what you have as of year 39. Okay? Year 39, you look into the future. The value of your retirement income is $90,000, about $90,000. And then $90,000 can be made by investing as of time zero, $1,085. Put it in your account and let that grow at 12%. And year 39, you will have almost the same amount. Notice that initially I look at the problem as of time zero. The ones in red is I look at the problem as of year 39. So align myself to a particular year, year 0 or year 39 or year 44, and then computing the same thing. You will get the same answer. No matter which way you go, you will get the same answer. Okay, that's that. Now here is annuity. Special case of annuity. Special case of multiple cash flows is like this. You have level cash flows over a period of time. Okay? It's called annuity. And here's a simple example. I'm not going to use the example in the lecture note. I will use a different example that I made up right before I came to this class. Okay, now who should I try? Is there anyone who has bought a lottery? Lotto? Anybody has any experience of buying a lotto? Nojisu, you have an experience of buying a lotto? Okay, let's suppose that Nojisu won a lottery. Okay, and this lottery pays the following cash flows. Okay, amazingly, she is rich. Times 0, 1, and 2, and 3. This lottery pays 100 million won per year for 3 years. 1억 won, 1억 won, 1억 won. Okay? 100 million won per year over 3 years. This is lottery. She won 300 million won. But actual value will not be 300 million won because each 100 million is to occur 1 year, 2 years, and 3 years ahead. Right? So actual value, present value will be smaller than that because $1 next year is worth less than $1 today. $1 2 years down the road is worth less than $1 1 year down the road. So we would like to find the present value of it. A simple way is to discount it back once, discount it back twice, and discount this 3 times. So 100 divided by 1 plus, let's say that 5% is the interest rate. 0.5 plus 100 divided by 1.05 squared plus 100. 1.05 cubed. Compute. How much is it? This is the present value of this lottery income. $272. Okay, that's just reasonable enough. 272. It's not 300. It's smaller than 300 because of the time value of money. It's kind of cumbersome. For 3 cash flows, it may not be too difficult, but suppose you have 15 of those 100s. Do this calculation really makes your fingers very tired. So what you can do is simplify this mathematical arithmetic, okay? Take 100 out of the equation. Take that out, and it will be 1.05 plus 1 over 1.05 squared plus 1 over 1.05 cubed. Or in terms of mathematical notation, sorry about this mathematical notation, but what can you do? 100 times summation t starting from 1 through 3, 1 over 1 plus r to the tth power. Right? This is a geometric progression. And there's a mathematical, the function for this notation, and that is equal to 100 times this much you have to, unfortunately, memorize, okay? This is another one that you should memorize. 1 over r minus 1 over r times 1 plus r to the tth power. Done. Done. This is present value of an annuity. Present value annuity factor, PVAF, with interest rate R and time period T. Okay, let's go present value annuity factor. In the old days, when we don't have a calculator, your textbooks had mathematical tables and present value tables, present value annuity tables, and all the tables are there. And we have to read the number, present value annuity factor, times 100. That's what we did. But with a calculator handy, like yours, there's no need to use the table. In the old days, I used to provide future value, present value tables together with an exam. No, I'm not going to give you tables. Okay? For your exam, bring your calculator. Okay? Use your calculator. Again, I'm not going to allow you to use your smartphone. Okay? But you can use your calculator. Bring your calculator to an exam. Okay? Can you do it? This much you have to memorize. This much you have to memorize. And this kind of cash flow is called annuity or ordinary annuity. It is ordinary because ordinarily the first cash flow occurs at the end of the period. It is ordinary, customary, that annuities' first payment is always at the end of the period. Okay? End of the first period, end of the second period, end of the third period. There are sometimes annuity that pays at the beginning of the period, like starting from time 0. That kind of annuity called annuity due. Annuity due is a different kind of annuity. We are more concerned with ordinary annuity or deferred annuity. The first cash flow is deferred to the end. So deferred annuity, ordinary annuity, or annuity, they are all the same thing. Okay. This is the formula. This formula is the same as that formula I gave. Just bring R up there, 1 over R minus 1 over R times 1 plus R to the 5th power. Now, suppose this annuity occurs over many, many, many periods, like 100. Then what will happen to this formula? 1 plus R to 100th power. This will become very large. Therefore, this fraction will become very small. If t becomes infinity, what will happen? T becomes infinity, this one will become 0. Therefore, present value of infinite annuity, called perpetual annuity or perpetuity, is C over R. Cash flow divided by R. That will give you the value of perpetual annuity. Annuity that lasts forever. Is there a practical instrument that is it available in practice? Yes. A couple hundred years ago, when Britain, at the time it's called Great Britain was at war against France. And Britain's government needed money to buy weapons, to buy arrows and bows and swords and spears and shields and cannons and rifles and guns. Okay? The war is very expensive to manage. It has to collect tax to pay for the war, but tax revenue is not enough. So what it did is it issued bonds. It issued bonds to the people, and the people bought the bonds, but those bonds did not have any maturity. There's no maturity. Maturity hasn't come due yet. It is still paying interest only, forever. It's that kind of bond is called British Consul. British Consul. It's a perpetual bond with perpetuity. Okay? Perpetual bond is actually available. Preferred stock is another example of perpetual bond. Now, here, annuity sweepstakes example, very similar to the one you've seen on the board. Okay? So you do it instead of I do it. Buying a house. I don't have time to go through this. I am going to work on this problem next class. Okay? When we come, I will begin discussing this buying a house example. And then rest of the class materials, you can read for yourself and you learn by yourself. Here are the problems that I am assigning, and by Monday, I want you to try all these. right? I gave you 5 problems on Monday, and today I'm giving you additional 5, and on Monday I'm giving you still another 5, so that you will have done total of 15 problems by next Wednesday. And as I said, on Monday and Wednesday we'll solve some of these problems. I want you to use your fingers, okay? Do all the problems by yourself. You have to get your hands dirty in order to learn this stuff. This stuff requires you a lot of practice and exercise. Okay, that's all for today, folks. I'll see you on Monday. Have a nice weekend.